Hello everyone. This is the answering session to Exam 3 review questions. Exam 3 covers chapters 9 and 11. Okay, let's go on to the first question. For a given sample size, when we increase the probability of type 1 error, the probability of type 2 error will what? The answer is C. It decreases. Why is that? It's because this is so because we know the type 1 error and type 2 error are having a trade-off relationship. In other words, if type 1 increases, if one increases, the other has to decrease. If you remember, I give you the example of using criminal justice to illustrate the situation. Type 1 error is that we reject null when it's true, or it's like we put an innocent person in jail. Type 2 error is if we fail to reject null when it's false. That is that's like when we let the criminals go free, right? And the two are having a trade-off, because if you want to increase type 1 error, for example, or let's say you decrease type 1 error. Type 1 is put innocent person in jail. If you do not want to put that many innocent person in jail, what do? You put fewer people in jail, or maybe you put nobody in jail. And then if you put nobody in jail, what's happening to the criminals? You're actually making it possible for more criminals to go free. Therefore, when you're trying to reduce type 1, you actually increase type 2. So that's the relationship, right? First one. Second question. After testing a hypothesis, we decided to reject null. Thus, we're exposed to what? The answer is to type 1 error. Why? What is type 1 error? Type 1 error is you reject null when it's true, right? Now we already decided to reject null. Therefore, we're only exposed to type 1 error. Will we expose to type 2? No. The type 2 error is you fail to reject null when it's false. If you already rejected, it's not possible that you fail to reject it. So this B is wrong. And this, of course, is not neither C or D nor D is correct. Okay. Number 3. Which of the following is correct? When sample size increases, both alpha and beta may decrease. That's probability of type 1 and type 2. We know that is true, right? And when using criminal justice as example, we can see that when court, ruled on more cases, many cases, they're more experienced, they're less likely to put an innocent person in jail, and less likely to let criminals go free. Okay. That's number 3. Number 4. Which of the following is correct? Okay. The level of significance is the probability of making a type 1 error. That is the correct statement, but it's not the correct answer. Okay. The question is which of the following is incorrect. Lowering both A and alpha and beta at once will require higher sample size. That is true also. Is in this case, in the question number 3 also. That's a true statement, therefore it's an incorrect answer. The C, the probability of rejecting a true null hypothesis increases as n increases. We know that's incorrect, because as n increases or sample size increases, the probability of rejecting true null is decreased. Therefore, this is a wrong statement. Therefore, it's correct answer to question number 4. Which of the following statement is correct? Right? Increasing alpha will make it more likely that we reject null, ceteris paribus. Or that is true, because when you increase alpha, we're more likely, to reject null, because alpha is the probability of reject null when it's true. The other are simply not true. Okay. And let me see, we go back down here. Okay, now let's look at question number 6 here. I believe your airplane's engine is sound, states the mechanic. I've been over it carefully and can't see anything wrong. I would be happy to tear the engine down completely for an internal inspection at a cost of $1,500. But I believe that the engine roughness you heard in the engine on your last flight was probably just a bit of water in the fuel, which passed harmlessly through the engine and is now gone. As pilot considers the mechanic's hypothesis, the cause of type 1 error is what? Okay. First, let's look at the hypothesis. What are the hypotheses? What is HO and H1? HO, the normal state, the usual state is, of course, the airplane is okay, the engine roughness is not that bad, as the mechanic said. H1, the alternative is what? H1 should be the engine has something wrong with it. The airplane is not suitable to fly. So what is the type 1 error then? The type 1 error in this case is that you reject null when it's true. Reject null when it's true, which H null is true, that means the airplane is okay, it's fine. But the pilot, rejected it, believing that the airplane is not good. And if it's not good, has problem, then what does he do? He will ask the mechanic to do an inspection, and that will cost him $1,500. Of course, we know the airplane is fine, so after the inspection is done, he will find out that there's nothing really wrong. So therefore, B, the pilot will be out $1,500 unnecessarily, and that is the true case, the consequence of type 1 error, right? And the rest is just simply not true. Okay. Next question, number 7. You're driving a van packed with camping gear total weight of 3,500 pounds, including yourself and family, into a northern wilderness area. You take a shortcut which turns into a one-lane road with no room to turn around. After 11 miles, you come to a narrow bridge with a faded sign saying safe up to 2 tons. In case you're not familiar with this, 2 tons is about 4,000 pounds. About a half mile ahead, you can see that your road rejoins the main highway, so there's hope there. You consider the science hypothesis carefully before making a decision. Excuse me. The cause of type 1 error in this case is what? Excuse me. Let's see. What is the HO and H1 in this case? HO is that the bridge is normal, it's okay, it's fine, no problem, it's safe up to 4,000 pounds. So your cargo of 3,500, it should be okay, right? What if what is the type 1 error in this case? That is, you reject null when it's true. So when it's true, meaning the bridge is indeed safe and sound, but you reject null. You believe that it is not the case, right? It's not true. So you believe that there's something wrong with the bridge. It's not going to be able to stand your weight, your cargo, your gear, everything, your van. So what do you do then? You will have to, basically this is a one-lane road, no room to turn around. You have to back all the way and up. So what's going to happen then? Your kids will think you're a chicken, right? So that is the correct answer. Yeah. That's type 1 error. Next one. For a red-tailed test of hypothesis for a single population mean with n equals 14, the value of test statistic was 1.863. The p-value is what? Right? Basically, if you can review your textbook on page 5, in chapter 9, you'll find that in Excel, you can use Excel to do this. In Excel, in any cell in Excel spreadsheet, you can just type in equal norms this 1.863. That'll give you the probability of 0.96876A. 1 minus that will give you 0.03123. Okay, 0.03 1, 2, 3 is, of course, is between 0.05 and 0.025. Therefore, A is correct answer. Okay, and you can alternatively, you can also look at your book. You turn to page 565, table C2. You will see that the probability is 0.96862. It's close to this. So, but you should get the same answer. Okay. Turn to next question. The critical value of the test statistic is what? C is the correct answer. It separates the acceptance and rejection region. That's what we use critical value for. Okay. It's calculated from sample data. No, that's not true. The test statistic is calculated from sample data. The critical value is not. It's usually 0.05 or 0.01 in most statistical cases. No, that's not true. No, that is it's just the 0.05 and 0.01 is the confidence level we normally choose. Is it determined by test statistics? No, it's not. Okay. The critical value is actually from the table, from the standardized table. Okay. Number 10. Dalco Manufacturing claims that these alkaline batteries last at least 40 hours on average. 40 hours here, okay, on average, in a certain type of portable CD player. But tests on a random sample of 18 batteries from a day's large production runs show the mean battery life of 37.8 hours, with a standard deviation of 5.4 hours. To test Dalco's hypothesis, the test statistic is what? Test statistics. What is the equation of you doing test statistics? Is X bar minus mu over sigma over the square root of n, right? So therefore, X bar minus mu, X bar in this case is 37.8, the mean life. Mu is the true value, true mean is 40 hours. It's actually here, 40 hours over sigma is 5.4, 5.4 times square root of n. N in this case is 18 batteries. So if you carry out the calculation, you should get minus 1.728. Therefore, B is correct answer. Okay. Number 11. When testing the hypothesis, HO mu is 100, n is 100, sigma squared, that's variance 100, we find that the sample mean is 97. The test statistic is what? Again, same equation using question number 10. X bar minus mu over sigma square root of n is 97 minus 100 over 10 over the square root of 100. Square root of 100 is 10. 10 over 10 is 1. So basically you have 97 minus 100. That is minus 3. Therefore, A is correct answer. Okay. Number 12. Given normal distribution with sigma 3, we want to test the hypothesis mu, HO is mu equals 20. We find that the sample mean is 21. The test statistics is what? In this case, what else do we need? We need the sample size, but we don't have it. We don't have n. Therefore, it's impossible to find out without more information. That's the correct answer. Number 13. In a left tail test, a statistician got a z-test statistic of minus 1.720. What is the p-value? Okay. Excuse me. I don't know why this is coming up. Right here. What is the p-value? For this question, you need to go to page 564 of your book. Look at the table C2. You'll see the p-value in that case is 0.0427. Therefore, C is correct answer. Okay. Again, this is on page 564 of your book, table C2. Number 14. Which is the Excel function to find the critical value f for alpha 0.05, degree freedom 3, and degree freedom 1 is 3, degree freedom 2 is 25. And in the Excel function, all you have to do is type in find FINV given the given the alpha and 2 degrees of freedom. You will find the critical value. And you can also, this is actually on page 410 of chapter 11. Okay. Number 15, which is not an assumption of ANOVA. Normality of the treatment population. This is an assumption, one of the assumptions of ANOVA. Homogeneous treatment variances, that is also assumption. Independent sample observation, that's also assumption. So all three are actually assumptions of ANOVA. Equal population sizes for groups, we know that's not true because you do not have to have equal sample size for different treatment groups. So this is true, not true, and it's a correct answer. Okay. Number 16. In ANOVA, when would the F-test statistic be 0? Okay. When F is 0, that means mean square for a treatment, MSA, is 0. So when is that mean MSA 0? That's when SSA is 0, or sum of square between groups is 0. So that's exactly what this is. When treatment means are the same, then sum of square between group is 0. Therefore, F will be 0. Okay. Number 17. Which of the following is not a characteristic of F distribution? It's not. Be careful with this wording here. Okay. It's always right-skewed. We know that's true. It describes the ratio of two variances. We know that's true also. It's MSA over MSE. It's a family based on two sets of degrees of freedom. We know that's true also. Denominator freedom, degree of freedom, and numerator degrees of freedom. It's negative when an inverse relationship exists. We know that's not true. It's never negative. Okay, so D is the correct answer. Number 18. Which of the following is not a characteristic of F distribution? Is a continuous distribution, we know it's true. It's never negative, that's true. It describes ratio of two sample means, that's actually wrong. Why? It's actually the ratio of the two variances, not means. So this is wrong. This part is wrong. It's always positively skewed, that's true also. Okay. Number 9. Degrees of freedom for the between group in the one factor ANOVA with NE1 equals 5, N2 6, and 3 C would be what? Right. The degree of freedom for between group, that degree of freedom is C minus 1, right? C minus 1, C is the number of groups in the case. Now how many groups do we have in here? We know it's N1, the first group has 5 observations, N2, second group has 6, the third group has 7. So there are 3 groups. Therefore, the degrees of freedom for 3 groups is 3 minus 1, N minus 1 equals 3 minus 1 equals 2. Therefore, D is correct answer. Okay. Number 20. Given the following ANOVA table, some information is missing. Find the critical value of F.05. Okay. How do you find that out? Do you need any calculations? You don't. Basically, find the critical value is not calculated from the sample. Then where do you find the critical value? You need to go to page 570 of your book. You will see that the critical value is 3.06. Okay, it's a little bit tricky here. Okay, this is correct answer, but it's not from the sample statistic. It's from the book. Number 21. For this one factor ANOVA, some information is missing. How many treatment groups were there? Okay. How do you find out the number of treatment groups? You know the sum of square. This is between treatment groups. Between groups treatment here. The sum of square is 641. Mean square is 218. But we don't know the degrees of freedom. How many groups? We don't know the number of groups, right? But we do know mean sum of squares and mean squares. If we know this one and this one, then this divided by that you should give you the degree of freedom here. And we know the degree of freedom for treatment is n-1, is C minus 1. So 654 times 218 gives you 3. And 3, C minus 1 equals 3, therefore C has to equal 1 plus 3, that is 4. So that is the 4 groups involved in this ANOVA. C is correct answer. Number 22, for this ANOVA factors, one factor ANOVA, what is the F test statistic? How do you do test statistics? Basically, all you have to do is you know the F mean square sum between group mean squares. You know the error mean squares. The ratio of 218 over 128, that's your F statistic. So 218 over 128, you carry out the calculation, it should be 1.703. Okay. Number 23, for this ANOVA results, degree of freedom for between variations are, in other words, you need this here, right? You need degree of freedom for between groups. And now you have the mean square. How do you calculate degree of freedom? You need the sum of square. Sum of square divided by mean square will give you degree of freedom, right? Degrees of freedom. But if you don't have sum of square between groups, but you do have within group and total, we know the total is the sum of square between plus sum of square within. So this minus that should give you the sum of square. And that divided by this will give you the degree of freedom. You carry out the calculation, it should be 3. Okay? That's 23. 24. Refer to the following partial ANOVA results from Excel. Okay? The critical value of F at 0.05 is what? Again, do you need to test do you need the sample statistic to calculate that? No, because you're looking at critical value, therefore where do you go? You go to page 570 of your book, look at the table, you'll find this is the correct answer. Okay? Number 25. The Internal Revenue Service wishes to study the time required to process tax returns in 3 regional centers. A random sample of 3 tax returns is chosen from each of 3 centers. Time in days required to process each return is recorded as shown below. Subsequently, an ANOVA test was performed, and from East, West, and Midwest region of the country. The degree of freedom for the error sum of square, it would be what? Okay. Degree of freedom of error sum of square, we know that equals n minus c. N is sample size, c is number of groups, right? Now what is n here? That's total number of observations. We know you have 3 observations in each of the 3 regions. The total n equals 9 and c equals 3 because we have 3 groups, right? N minus c equals 9 minus 3, that is 6. Therefore D is correct answer. The last question is not required because I did not require this for your in the lecture. Did not require this of you for your exam, but just so you know, this is called for the Hartley's test for homogeneity of variance. It equals, actually, just so you know, equals the variance, the maximum variance over the minimum variance. And which one of the four groups here, which one has the maximum variance? And first, we don't have variance here, but we do have standard deviation, right? How is the variance calculated? That's standard deviation squared. So the largest one, if you look at the 4 here, is 8.944. The smallest one is 3.983. So basically 8.944 squared over divided by 3.983 squared will give you the answer, the Hartley's test. If you carry out 8.99 squared divided by 3.98 squared, you get a 5.04. But again, this is not required for your test. Okay. With that, we conclude the review session, answering a review session for exam 3 review questions. Good. good luck with your test.